Imagine looking at a galaxy, billions of stars glowing across the darkness of space. Now imagine that all of those stars are moving, but they are moving far too fast. Fast enough that, according to everything we can see, the galaxy should be flying apart, and yet it isn't. Something invisible is holding it together, something we cannot see, something that does not seem to emit, absorb, or reflect light. We call it dark matter. But what exactly is it? To understand dark matter, we need to look at how galaxies move. Gravity tells us that objects farther from the center of a galaxy should generally orbit more slowly. Closer to the center, the gravitational pull is stronger. Farther away, the pull should become weaker. But when astronomers measured the rotation of galaxies, they discovered something strange. The outer stars were moving much faster than expected, and they weren't escaping. Something was providing additional gravity, something we couldn't see. Astronomers realized that the visible stars and gas couldn't account for all of the gravity. There had to be much more mass than we could observe. This invisible mass appeared to surround galaxies in enormous halos. The stars were essentially moving through an invisible gravitational structure. And this mysterious material became known as dark matter. Dark doesn't mean that it is simply black. It means that it does not interact with light in the ordinary ways that familiar matter does. We can't see it directly, but we can see what its gravity does. And the evidence doesn't stop with individual galaxies. Look at galaxy clusters. These are enormous collections of galaxies bound together by gravity. When astronomers measure the motions of the galaxies inside them, they find far more gravitational mass than the visible matter can explain. There is another clue. Hot gas inside galaxy clusters emits enormous amounts of X-rays. Yet even the stars and gas together aren't enough to explain the gravitational effects we observe. Again, something invisible is there. Now comes one of the most beautiful pieces of evidence: gravitational lensing. According to Einstein's general relativity, mass curves space-time. And when light travels through curved space-time, its path can bend. So astronomers can use distant galaxies as cosmic background lights. If their light is distorted by something in the foreground, we can map the mass causing that distortion. And sometimes, the amount of mass inferred from the lensing is far greater than the amount of visible matter. The invisible gravitational influence is revealed. Dark matter leaves a shadow, not in light, but in gravity. One of the most famous examples is the Bullet Cluster. It formed when two enormous galaxy clusters collided. The ordinary matter, especially the hot gas, interacted strongly and was slowed down. But the gravitational mass inferred from gravitational lensing appears largely separated from that gas. It's as though an invisible component passed through the collision, while the ordinary matter experienced resistance. The result provided powerful evidence that most of the gravitating matter is not ordinary matter. Something else is there: dark matter. Dark matter also appears in the earliest light we can observe. The cosmic microwave background is the faint afterglow of the early universe. It contains tiny variations in temperature and density. These fluctuations preserve information about the ingredients of the cosmos. When scientists compare observations with cosmological models, they find that ordinary matter alone cannot reproduce what we see. Dark matter plays a crucial role. It provides gravitational wells into which ordinary matter can eventually fall. Without it, the universe would have had a much harder time building the galaxies and large-scale structures we see today. Over billions of years, gravity amplified tiny differences in the early universe. Dark matter began clumping together. These invisible structures formed a vast cosmic web. Ordinary matter followed the gravitational landscape created by this hidden mass. Galaxies formed along the filaments. Galaxy clusters grew where the structures intersected. And on the largest scales, the universe became a gigantic cosmic network, a structure shaped by something we cannot directly see. But what is dark matter actually made of? We don't know. That's one of the greatest mysteries in modern physics. Scientists have proposed many possibilities. One idea involves hypothetical particles called WIMPs, weakly interacting massive particles. Another possibility involves extremely light particles called axions. There are also other proposed candidates, but so far, no dark matter particle has been conclusively detected. We know something behaves as though it has mass. We know its gravity affects the universe, but we don't yet know its fundamental identity. So scientists are trying to find it. Some experiments are buried deep underground, far away from cosmic rays and other sources of interference. The idea is simple. If dark matter particles pass through Earth, perhaps one of them will occasionally collide with an atom inside a detector. The resulting signal could reveal the particle's existence. Other experiments search for signals produced when dark matter particles interact or decay. And particle accelerators search for evidence of dark matter being produced in high-energy collisions. So far, the mystery remains. And here's the truly astonishing part. Dark matter appears to make up a large fraction of the matter in the universe. Ordinary matter, the atoms that make stars, planets, people, and everything we can touch, is only a small part. Dark matter is thought to account for roughly 5 times as much matter as ordinary matter. And beyond both of them, there is another even stranger component: dark energy. Together, dark matter and dark energy dominate the cosmic inventory, which means that most of the universe is made of things we still don't fully understand. So, what is dark matter? We don't know, and that may be the most honest answer in science. We know it exists because of its gravitational effects. We see galaxies rotating too quickly. We see light bending around invisible mass. We see galaxy clusters behaving as though additional matter is present. We see its fingerprints in the cosmic microwave background, and we see its influence written across the largest structures in the universe. But we still haven't caught the thing itself. Perhaps dark matter is a new kind of particle. Perhaps it belongs to a hidden sector of physics. Or perhaps our understanding of gravity itself is incomplete. For now, the universe is giving us a remarkable clue. There is something out there, something massive, something invisible, something shaping the cosmos, and we don't yet know what it is. We cannot see dark matter, but without it, the universe we see may never have formed.